Take a slow, deep breath in, letting the cool, quiet air fill your lungs. And as you exhale, allow your body to completely settle into the soft, comforting weight of the space beneath you. Tonight, we are leaving behind the noise and the friction of the waking world to journey into the profound, peaceful expanses of deep space, to discover the quiet joy of solitude. Right now, stretching endlessly in all directions, the universe is bathed in the faint, ancient glow of the cosmic microwave background radiation. This is the afterglow of creation itself, and it gives the deepest, most isolated pockets of space a resting temperature of exactly 2.7 Kelvin, which is roughly negative 455 degrees Fahrenheit. You might wonder why that matters. It matters because this incredible cold is not harsh. It is the ultimate thermal blanket, a steady, unchanging baseline that slows down the kinetic movement of atoms, bringing the physical universe into a state of profound, undisturbed rest. Imagine stepping out of a loud, sweltering room into a perfectly cool, crisp winter night. That is the feeling of entering the cosmic void. In our day-to-day lives, we are constantly surrounded by matter. The air you are breathing right now at sea level contains about 25 quintillion molecules in every single cubic centimeter. It is a thick, invisible soup of nitrogen, oxygen, and trace gases, constantly brushing against your skin. But as we drift outward, past the bright and busy neighborhood of our solar system, we enter the interstellar medium. Here, the density of matter drops to an astonishingly sparse average of just one single atom per cubic centimeter. Consider this near-perfect emptiness. Without a dense atmosphere to create friction, there is no resistance. If you were to glide through this space, you would feel a perfect, glassy smoothness. There is no drag, no wind to push against you, no turbulence. You could travel effortlessly, floating in a state of perpetual, weightless grace. Because there is no air, there is also an absolute physical silence. Sound is merely a mechanical wave that requires a medium, like air or water, to vibrate through. In the interstellar void, where atoms are too far apart to bump into one another and transfer acoustic energy, true silence is a law of physics. It is a quiet so deep and protective that it allows the mind to completely unravel and relax. Let us travel toward one of the most majestic and solitary regions ever observed by human astronomers. In 1981, astronomer Robert Kirshner and his colleagues discovered an expanse of space known as the Bhuta's Void. This is a spherical region of the universe that is utterly, magnificently isolated. The Bhuta's Void is roughly 330 million light-years in diameter. To put that into perspective, it accounts for nearly 0.25% of the entire observable universe. In a typical region of space this vast, gravity would have pulled together at least 2,000 distinct galaxies, forming bright, bustling clusters. Yet, within the sprawling, quiet architecture of the Bhuta's Void, scientists have discovered only about 60 galaxies. This means the distance between these lone, drifting islands of stars is unimaginably vast. If our own Milky Way galaxy were located in the very center of the Bhuta's Void, we wouldn't have even known other galaxies existed until the invention of deep space telescopes in the 1960s. Imagine the peacefulness of residing in such a place. It is a velvet expanse where the night sky would be virtually empty of distant galactic smudges, offering instead a serene, unbroken canvas of black silk. The Bhuta's Void isn't empty. It is simply uncrowded, a cosmic sanctuary offering the ultimate undisturbed peace. As we continue our gentle drift through the dark, we encounter wandering celestial bodies that have embraced their own form of solitude. For most of human history, we believed that planets could only exist in orbit around a warm, glowing star. But in the early 2000s, astronomers confirmed the existence of rogue planets, worlds that have broken free from the gravitational tethers of their birth stars to float independently through the dark ocean of the Milky Way. Here is something remarkable. In 2012, astronomers discovered a rogue planet candidate designated CFB-DSIR 2149-0403, drifting freely about 100 light-years away from Earth. It has no sunrise, and it has no sunset. It answers to no solar calendar. It is untethered, experiencing a perpetual, quiet twilight. Without the blinding glare of a parent star, a world like this is bathed only in the soft, distant silver pinpricks of background starlight. Even closer to home, just 7.27 light-years away, there is an isolated object known as Y0855-0714. This is a sub-brown dwarf, a celestial body that is heavier than a planet, but not quite massive enough to ignite nuclear fusion and become a star. Drifting alone, its surface temperatures are remarkably similar to our own extreme climates, ranging between -55 and 9 degrees Fahrenheit. Telescopic data suggests the presence of water clouds in its atmosphere. Close your eyes and sense the texture of such a world. A cool, quiet sphere, wrapped in thick layers of atmospheric frost and swirling silent clouds. It requires nothing. It simply exists, beautiful and self-sufficient, coasting through the frictionless dark. Even our own solar system possesses a quiet, solitary frontier. Far beyond the warm, rocky planets, and far past the icy gas giants, lies the Oort cloud. This is a massive, spherical shell of icy debris that surrounds our solar system. And it is immense. The inner edge of the Oort cloud begins roughly 2,000 astronomical units from the Sun. Keep in mind that just one astronomical unit is 93 million miles. The distance from the Earth to the Sun. The outer edge of this quiet, frozen halo extends up to 100,000 astronomical units away, reaching nearly halfway to the nearest neighboring star. Out here, in the deep freeze of the Oort cloud, the Sun is no longer a large, warming disk. It is merely the brightest star in a profoundly dark sky. In this remote territory, astronomers discovered a dwarf planet in 2003 named Sedna. Sedna is a world of exquisite isolation. It traces an incredibly wide elliptical path around the Sun. In fact, a single year on Sedna, one complete orbit, takes roughly 11,400 Earth years. Think of the rhythmic, almost hypnotic slowness of that journey. Entire civilizations rise and fall on Earth, mountain ranges erode, and oceans shift, all while Sedna slowly, quietly, completes just a single majestic loop through the dark. Because it is so incredibly distant, Sedna is preserved in a state of eternal chill. The temperature on its reddish, rocky surface rarely rises above -400 degrees Fahrenheit. The red color is thought to be caused by tholins, complex organic molecules that form when ultraviolet light bakes simple ice over billions of years. Imagine the smooth, hard texture of a landscape carved entirely of ancient ice and dusted with this dark red organic snow. There is no wind to disturb the surface, no tectonic rumblings, only the slow, silent rotation of a solitary world, keeping perfect time in the dark. Humanity, too, has sent an emissary into this quiet joy of solitude. In 1977, NASA launched the Voyager 1 spacecraft. Today, It is the farthest human-made object in existence, currently drifting over 15 billion miles away from Earth. It has crossed the heliopause, the invisible boundary where the solar wind, the stream of charged particles from our sun, finally fades and gives way to the interstellar medium. Traveling at an astounding 38,000 miles per hour, Voyager 1 makes absolutely no sound in the vacuum. It carries with it a golden record, a phonetic greeting, slipping silently through the void, like a message in a bottle cast into the deepest ocean. To be Voyager 1 is to be entirely detached from the noise of the Earth, embraced by a galaxy that offers no resistance, gliding endlessly onward through the cool dark. Even entire galaxies can be recluses. Consider the galaxy UGC 1382, located an astonishing 250 million light-years away from us. For a long time, astronomers thought it was just a small, unremarkable elliptical galaxy. But through multi-wavelength observations, they realized it is actually a colossal Frankenstein galaxy. It spans an enormous 718,000 light-years across, making it more than 7 times wider than our own Milky Way. Yet, it sits alone in a sparsely populated region of space. Its massive rotating arms of gas and ancient stars sweep through the void in perfect undisturbed isolation. It is held together by an immense halo of dark matter, an invisible scaffold that provides gravity without catching or emitting a single photon of light. This invisible architecture cradles the solitary galaxy, keeping it safe and intact as it slowly turns, like a giant silver pinwheel in the dark. As you sink deeper into your resting space, let the physical reality of this cosmic solitude wash over you. The universe is not a chaotic, crowded place. At its grandest scales, it is primarily composed of this beautiful, empty room. It is a place where rogue planets drift in perfect peace, where giant voids offer a sanctuary from gravity's pull, and where temperatures hold the ancient chill of the universe's beginning. This is a solitude that doesn't isolate, but protects. It is a quiet that doesn't just empty the mind, but fills it with the soft, steady rhythm of celestial mechanics. Let your breathing match the slow, patient orbit of these distant, solitary wanderers, sinking deeper into the frictionless, quiet dark. In song, continuing this silent outward glide, we find ourselves reflecting on how humanity first attempted to comprehend such a profound cosmic stillness. For much of written history, the true nature of this physical emptiness was deeply misunderstood. Tracing back to the 4th century BCE, the philosopher Aristotle proposed that the space between the stars could not possibly be empty. He, alongside countless scholars who followed, believed the heavens were filled with a frictionless, invisible fluid known as the ether. It was thought to be a divine substance that held the celestial bodies in place, an unseen ocean carrying the planets along their paths. It was not until the year 1887 that the famous Michelson-Morley experiment fundamentally dismantled this ancient belief. By measuring the speed of light in perpendicular directions, the physicists Albert A. Michelson and Edward W. Morley proved that there was no ether wind dragging against the Earth. Space, they confirmed, was a true vacuum. Think of this revelation as replacing a heavy phantom ocean with an infinitely clear, breathable glass bell jar. Light and gravity travel through this pure emptiness without needing a physical medium to carry them. There is an incredible lightness to this realization. The void is not a dense fluid you must swim against. It is an open, unresisting theater of pure potential. Historically speaking, early astronomers were often startled when they stumbled upon regions of space that seemed too quiet, even by cosmic standards. In 1785, the British astronomer William Herschel aimed his brass telescope toward a glittering, densely packed region of the Milky Way within the constellation Scorpius. Expecting to see a continuous, sparkling tapestry of starlight, he was completely stunned to find a patch of absolute starless blackness. Surprised by this sheer visual silence, he famously recorded in his notes, "Truly there is a hole in the heavens." What we now understand is that Herschel had not found a hole, but a dark absorption nebula. This specific object was officially catalogued in 1919 by the American astronomer Edward Emerson Barnard, and it is known today as Barnard 68. Located approximately 500 light-years from Earth, Barnard 68 spans roughly half a light-year across. Picture a single heavy drop of black ink suspended perfectly in a pool of clear water, absorbing the surrounding light without creating a single ripple. That is precisely how Barnard 68 behaves. It is a molecular cloud packed with microscopic dust grains and cold gas that actively blocks the visible light of the stars sitting behind it. Deep within the core of this dark nebula, the temperature drops to an incredibly frigid 16 Kelvin, which is about -430 degrees Fahrenheit. Because the dust shields the interior from the warming radiation of nearby stars, it remains one of the quietest, coldest, and most secluded sanctuaries in our local galactic neighborhood. Notice how soothing that concept is. A cosmic veil drawn closed, offering a patch of absolute shade against the relentless glare of a billion blazing suns. Even when we look at the space immediately surrounding our own planet, the Solitude is beautifully structured. At this very moment, our entire solar system is moving smoothly through a localized region of space named the local interstellar cloud, sometimes affectionately referred to by astrophysicists as the local fluff. Discovered through modern spectroscopic analysis, this cloud is approximately 30 light-years across. It is an exceedingly tenuous wisp of material, possessing a density of merely 0.3 atoms per cubic centimeter. If you could magically scoop up a handful of this cloud, you would find its composition is intensely simple. Roughly 90% hydrogen and 9% helium, with only the faintest traces of heavier elements. We are silently carving a path through this diaphanous mist. As the sun's magnetic field and solar wind push against this ultra-thin gas, they create a protective magnetic bubble called the heliosphere. We are riding inside a shielded solitary vessel, parting an invisible sea of ancient hydrogen as we travel. Consider the rhythmic, unhurried timeline of this journey. The Milky Way galaxy is constantly rotating, a majestic pinwheel turning in the dark. Our sun takes anywhere from 225 to 250 million Earth years to complete just one single orbit around the galactic center. Astronomers call this immense cycle a cosmic year. The pacing of this movement is the ultimate definition of patience. Since our sun formed approximately 4.6 billion years ago, it has only completed roughly 20 cosmic years. Allow the weight of these vast numbers to settle over you. 20 long, sweeping arcs around the galaxy. The last time our solar system was in its current position, the Earth was in the early Triassic period, long before the continents, as we know them, had drifted apart. The universe operates on a clock, so slow and deliberate that the anxieties of a single day simply dissolve into its grand, sweeping rhythm. As we look out across the space between the stars, we find neighbors, yet they are separated by gulfs of solitude that challenge human comprehension. In 1915, the Scottish astronomer Robert Innes analyzed photographic plates at the Union Observatory in South Africa. Through careful comparison, he discovered a faint reddish star that shared a proper motion with the bright Alpha Centauri system. He had found Proxima Centauri, the closest individual star to our own Sun. Despite being our most immediate stellar neighbor, Proxima Centauri sits 4.24 light-years away. To translate that into miles, you must picture a distance of 25 trillion miles. It is a solitary red dwarf, possessing only 12.5% of our Sun's mass, emitting a cool, dim crimson light that is invisible to the naked human eye on Earth. If we were to send a spacecraft matching the speed of the Voyager probes, coasting at 38,000 miles per hour, it would take over 73,000 years of silent, uninterrupted travel just to cross the gap to this closest neighbor. There is a deep comfort in recognizing the padding of distance between the stars. The universe provides ample room for everything to exist without crowding. Every star is granted its own sprawling, quiet domain. This solitude is not static. It is actively growing, softening, and expanding. In 1929, the brilliant astronomer Edwin Hubble made a discovery that forever altered human philosophy. By measuring the light from distant galaxies at the Mount Wilson Observatory, Hubble observed a phenomenon called redshift. The light waves traveling from these galaxies were being stretched out, shifting toward the red end of the electromagnetic spectrum. This Doppler effect provided undeniable proof that the galaxies were moving away from us. The universe itself was expanding. Decades later, in 1998, two independent teams of astronomers studying distant supernovae made an even more astonishing observation. Not only is the universe expanding, but the rate of that expansion is actually accelerating. This driving force was termed dark energy. Today, precise measurements calculate this expansion rate, known as the Hubble constant, to be approximately 68 kilometers per second per megaparsec. And what this means on a grand scale is that the fabric of space is slowly, gracefully unfolding. Galaxies are gently drifting further apart, pulling away from one another like ships scattering across an endless, calm ocean. Over trillions of years, the night sky seen from any given galaxy will grow darker and quieter as neighboring galaxies slip beyond the visible horizon. It is an ultimate unwinding, a cosmic exhalation that relieves all pressure and tension. The cosmos is not crashing together. It is stretching out, claiming more space, settling into a permanent, peaceful isolation. Breathe in the slow, ancient light of these separated stars. Recognize the profound quiet that has been observed and chronicled by generations of stargazers standing in cold observatories, peering up at the night. From Aristotle's imagined ether to Herschel's black void, down to Hubble's expanding horizons, humanity has always sought to understand the silence above. It is a silence that asks nothing of you. It simply offers an infinite, frictionless stage where ancient light travels uninterrupted and massive worlds trace their slow, predictable circles in the dark. Give permission to your own thoughts to stretch out alongside the expanding galaxies, thinning out, slowing down, and embracing the quiet joy of having nothing to push against. Stepping further into the boundless architecture of the cosmos, we find that even the smallest fragments of matter experience their own profound, solitary journey. Picture a single shaft of afternoon sunlight streaming through a window pane into a quiet, undisturbed room, illuminating dozens of tiny dust motes as they drift aimlessly in the air. Deep space possesses its own version of this familiar, lazy snowfall, known to scientists as cosmic dust. Every single year, approximately 5,200 metric tons of these microscopic particles gently sift down through Earth's atmosphere, settling invisibly onto the surface of our planet. Most of these individual grains measure less than 0.1 millimeters across. They are exceptionally ancient travelers, originating from the fragmented remains of comets and asteroids that formed 4.6 billion years ago during the birth of our solar system. Like fine flour passing through a sieve, they enter the upper boundaries of our mesosphere at speeds reaching up to 26 miles per second. Very quickly, atmospheric friction slows their descent, allowing them to softly parachute to the ground. In 2016, researchers living in deep isolation at the Concordia Station in Antarctica successfully harvested these pristine, untouched cosmic dust grains from the deep snowpack. There is a quiet poetry in knowing that as you rest, an invisible, weightless snow of ancient stardust is continually, silently falling across the globe. Look beyond the edges of our home galaxy, out into the sprawling geometry that separates the major galactic clusters. This is the intergalactic medium, a region of space so sparse it redefines the concept of emptiness. If the space between nearby stars seems secluded, the territory between galaxies is a masterpiece of physical minimalism. Out here, the density of matter plummets to a staggering average of just one single atom per cubic meter. To visualize this level of extreme isolation, imagine taking a single grain of beach sand and placing it alone inside a hollowed-out commercial cargo shipping container. That is the exact ratio of matter to empty space in the intergalactic void. This hyper-diffuse material, often referred to by astrophysicists as the warm-hot intergalactic medium, consists almost entirely of ionized hydrogen. It floats in absolute darkness, undisturbed by the gravitational pull of planets or the blazing heat of nearby suns. The atoms within this sparse mist are so far apart, they may travel for thousands of years without ever colliding. It is an environment of ultimate independence, where every tiny component is granted its own vast private room within the universe. Moving our attention to how larger celestial bodies navigate their solitary paths, we observe a mathematical harmony known as orbital resonance. Think of the precise interlocking gears of a vintage pocket watch, or the rhythmic swinging of a heavy pendulum. Far out in the twilight of our own solar system, the dwarf planet Pluto and the ice giant Neptune share a beautifully synchronized relationship without ever physically touching. Pluto traces a long elliptical path that takes 248 Earth years to complete a single orbit around our Sun. Meanwhile, Neptune walks a tighter circle, taking exactly 165 Earth years to complete its journey. Bound by the invisible elastic tether of gravity, these two worlds are locked in a strict 2 to 3 orbital resonance. This means that for every 3 trips Neptune makes around the Sun, Pluto makes exactly 2. Because their orbital paths actually cross one another, one might assume that eventually, over billions of years, they would tragically collide. Yet, governed by this mathematical clockwork, they are perfectly safe. They never approach closer than 17 astronomical units, which translates to an immense protective gap of 1.58 billion miles. They are like two skilled partners, engaged in a flawless, centuries-long waltz across a grand ballroom floor, sweeping past one another, but always maintaining a respectful, perfectly measured distance. Observe how this elegant choreography prevents chaos, substituting danger with a reliable, infinitely repeating rhythm. Deep within the constellation, Centaurus, situated roughly 5,000 light-years from Earth, exists a celestial structure that perfectly embodies the physical sensation of chilling tranquility. It is the Boomerang Nebula, officially recorded by astronomers as the coldest naturally occurring place in the known universe. The temperature inside this cloud plunges to a breathtaking 1 Kelvin, which equates to negative 458 degrees Fahrenheit. This specific region of space is actually colder than the faint cosmic microwave background radiation left over from the Big Bang itself. To understand how a nebula becomes colder than the surrounding void, we can look at a very common earthly experience. When you spray compressed air from an aerosol can to clean a computer keyboard, the metal tin immediately feels icy in your hand. This happens because the pressurized gas is suddenly expanding, causing its temperature to drop rapidly. The exact same principle of thermodynamics applies on a cosmic scale inside the Boomerang Nebula. The dying central star of this system is actively expelling its outer layers of gas at an astonishing velocity of 367,000 miles per hour. As this stellar material rushes outward and expands into the vacuum, it cools dramatically, creating a localized pocket of supreme freezing stillness. It is a cosmic deep freeze, a sanctuary of absolute thermal rest, where the energetic vibrations of atoms slow to an almost complete halt. Eventually, all fiery, energetic activity in the universe must yield to this state of permanent quiet. Observe the immensely patient life cycle of a white dwarf star. When a medium-sized star exhausts its nuclear fuel, it cannot sustain the outward pressure of fusion. It collapses inward, leaving behind a hyperdense, faintly glowing core. A famous white dwarf, such as Sirius B, is astonishingly compact. It packs the entire massive weight of our Sun into a spherical volume roughly the size of the Earth. The interior composition of these stellar remnants is largely composed of crystallized carbon and oxygen under extreme pressure. In fact, a specific white dwarf catalogued as BPM 37093, located 50 light-years away, is essentially a gigantic crystalline jewel. Playfully nicknamed Lucy by the astronomical community in homage to the famous Beatles song, this celestial object is a 4,000-mile wide diamond suspended in the dark. Measurements dictate it weighs an incomprehensible 10 decillion carats. Think of a heavy, solid piece of coal that has glowed red-hot in a hearth all evening, slowly radiating its remaining warmth into a dark, sleeping house long after the flames have vanished. A white dwarf undergoes this exact same cooling process, but on a timescale that challenges human imagination. It emits no new energy. It merely radiates its residual heat out into the empty dark. Astrophysicists calculate that it takes a single white dwarf upward of 1 quadrillion years, a 1 followed by 15 zeros, to completely cool down to the ambient temperature of interstellar space. Once it loses all its heat, it becomes a theoretical object known as a black dwarf, a cold, invisible sphere of compressed carbon drifting silently in the dark. Because our universe is currently only 13.8 billion years old, it is still far, far too young for even a single black dwarf to have formed anywhere in the cosmos. The process of reaching that ultimate silent state is so deliberate, so infinitely slow, that the entire history of life on Earth is merely a fraction of a second in comparison. Allow your breathing to match the unhurried, steady cooling of these ancient stellar cores. The universe is in no rush. It possesses an endless supply of time and space, allowing every burning star to eventually find its way back to a cool, quiet slumber. In the grandest physics of the cosmos, the ultimate destination is always peace, stability, and rest. Feel the deeply comforting weight of that certainty as the slow, majestic mechanics of the sky continue their silent turning. Have you ever stopped to think about the physical connection between your own observing mind and the deepest reaches of the cosmos? Science reveals that the everyday act of seeing is actually a highly intimate personal encounter with ancient history. Light, the messenger of the universe, travels at an absolute speed limit of exactly 186,282 miles per second. This fundamental law of physics dictates that the warming light striking your skin on a bright afternoon took precisely 8 minutes and 20 seconds to travel from the solar surface to our planet. You are never feeling the sun as it is right now, but rather as it was in the recent past. When you direct your gaze toward the Andromeda Galaxy on a clear night, a spiral formation officially designated by astronomers as M31, the soft starlight entering your pupil has crossed a staggering 2.5 million light-years of empty, frictionless space. Picture this ancient light as an incredibly patient cosmic postcard. The specific photons gently touching your retina tonight began their solitary journey through the vacuum 2.5 million years ago. To put that into a personal context, those photons departed Andromeda long before the genus Homo, our earliest human ancestors, had even evolved on Earth. This tiny packet of energy traveled unbothered through the freezing intergalactic dark for millennia, only ending its solitary, silent flight the exact moment it reached your optic nerve. You are, quite literally, physically intercepting a piece of the ancient universe, receiving a message that took millions of years to arrive precisely where you are resting right now. Reflect on the familiar, comforting presence of the moon outside your window. It feels like a permanent, unchanging companion in the night sky, yet it is quietly engaged in its own slow, majestic departure. The moon is tidally locked to our planet, meaning its rotation period perfectly matches its 27.3-day orbital journey around Earth. Because of this gravitational braking, it permanently shows only one face to humanity, keeping its far side hidden in perpetual mystery. However, due to a mechanical process called tidal friction, the swelling and subsiding of Earth's ocean tides are gradually transferring angular momentum out to our lunar companion. Laser-ranging experiments have allowed astrophysicists to track this movement with breathtaking precision. By firing targeted light beams at specialized retroreflective mirrors left behind in the lunar dust by the Apollo 11, 14, and 15 astronauts between 1969 and 1971, scientists measure the exact distance between our two worlds. Every single year, the moon drifts exactly 3.8 centimeters, about 1.5 inches, further away from the Earth. It is a peaceful, completely silent parting of ways. Over an immense time scale, this subtle drift carries profound long-term implications for the sky we know. In approximately 600 million years, the moon will have moved too far away to completely obscure the sun's disk from our vantage point, bringing a permanent, quiet end to total solar eclipses on Earth. This celestial relationship reminds us that even our closest neighbors are gently seeking their own solitary space over deep time, moving outward at the slow speed of a growing fingernail. Looking forward into the grand arc of the universe, we discover isolated pockets of warmth uniquely suited to harbor life, regions astrophysicists call habitable zones. This term designates a specific distance from a host star where the atmospheric pressure is roughly 1 standard atmosphere, allowing liquid water to pool peacefully on a planetary surface without instantly boiling away or freezing solid. Earth occupies this solitary protective ring around our sun at an average distance of 149.6 million kilometers. Let us turn our gaze to a much quieter, smaller system located 39.6 light-years away in the constellation Aquarius. In 2015, astronomers identified TRAPPIST-1, an ultra-cool red dwarf star. Red dwarfs are the universe's ultimate introverts. They burn their hydrogen fuel at an incredibly slow, frugal rate compared to massive, brilliant stars. While our own sun has a total estimated lifespan of about 10 billion years, TRAPPIST-1 is projected to steadily burn for up to 10 trillion years. Orbiting closely around this cool, dim star are 7 Earth-sized rocky planets, 3 of which reside comfortably within the star's habitable zone. Think of this distant system as a solitary, warmly lit greenhouse surviving in the middle of an endless freezing winter landscape. Because the star emits a low-energy infrared glow, any water on these worlds would shimmer under a sky of deep, permanent twilight. Long after larger, brighter stars have exhausted their fuel and faded away, these slow-burning red dwarfs will provide the last remaining sanctuaries of warmth in the cosmos. They are long-term harbors, ensuring that the necessary conditions for life can endure quietly for trillions of years into the future. The universe has built-in longevity, providing solitary shelters that outlast the dramatic, chaotic eras of galactic formation. It is worth noting that this profound, yet distant physics is directly responsible for the beating of your heart, the rhythm of your breath, and the very structure of the body you are resting in. The elements that comprise your physical form were not originally generated on Earth. They were forged in the solitary, crushing cores of ancient stars. Take the element carbon, the fundamental building block of all human biology. It is created through a complex nuclear reaction called the triple alpha process. Deep inside a massive star, at unfathomable temperatures exceeding 100 million Kelvin, 3 helium nuclei, also known in particle physics as alpha particles, are forcefully fused together, producing a single stable carbon atom. When these ancient massive stars reached the end of their solitary lives, they gracefully cast these precious elements out into the interstellar medium, creating beautiful expanding clouds called planetary nebulas, or detonating in spectacular supernovae. The iron that sits at the center of your hemoglobin molecules, responsible for carrying vital oxygen through your bloodstream with every inhale, required the extreme, fleeting energy of a dying star's core collapse to be born. At this very moment, your resting body is replacing roughly 330 billion cellular units every single day. To perform this quiet miracle, it is assembling those ancient starlight-forged atoms, weaving them seamlessly into muscle, bone, and tissue. Scientists have calculated that a staggering 73% of the atoms in your body by mass were generated by the dramatic deaths of massive stars billions of years ago. You are not separate from the quiet, dark vacuum of space. You are a living, a breathing extension of it. Notice how this immense realization brings a sense of deep personal grounding. The universe spent billions of years operating in absolute solitude, slowly crafting the exact elemental materials needed to form you. The calm isolation of deep space is not an alien, unwelcoming environment. It is your deepest point of origin. As you lie still, your internal biological systems are seamlessly carrying out the legacy of those ancient stellar cycles. Your body remembers the slow, patient work of the cosmos, quietly sustaining your physical form, relying on elements that traveled across immense distances just to become part of your story tonight. Allow the gentle gravity of that truth to anchor you firmly in the present, in the finding deep comfort in knowing that the quiet joy of the universe resides within your very cells. Gliding further outward into the boundless theater of the cosmos, we find that the sensory experience of profound isolation is far more intricate than simple darkness. To grasp the mechanics of this environment, we might pause to investigate the actual physical scent of the deep void. When astronauts aboard the International Space Station complete an extravehicular activity, stepping back inside and removing their specialized helmets, they consistently report a highly specific, lingering aroma clinging to their suits. They describe the scent of the solitary vacuum as a mixture of sharp ozone, hot metallic fumes, and seared steak. By examining the physics behind this phenomenon, researchers have decoded the origin of this unique perfume. The smell is generated by complex molecules known as polycyclic aromatic hydrocarbons, or PAHs. These specific organic compounds are forged in the intense high-energy combustion of dying stars. Once expelled, they wander alone through the interstellar medium for billions of years, occasionally drifting across the orbit of our planet and adhering to the fabric of spacewalking suits. Understanding why space smells like hot metal connects us directly to the ancient, quiet mechanics of stellar life cycles. The empty space surrounding our world is actually laced with the faint aromatic ashes of ancient stellar fires, a comforting reminder that even in complete isolation, the universe retains the memory of its glowing origins. What's happening now is a gentle shift toward the visual poetry of the dark. We're focusing on the breathtaking colors that paint the loneliest corners of our galaxy. When you view astronomical images of solitary glowing gas clouds known as emission nebulae, you frequently encounter a rich, velvety, luminous crimson. This signature color is not random. It is governed by a strict, elegant law of quantum mechanics, known as the Balmer series. Within these quiet clouds, singular hydrogen atoms float in near-perfect isolation. When a stray packet of ultraviolet energy excites the solitary electron orbiting a hydrogen nucleus, that electron jumps to a higher quantum state, but it cannot remain there. As the atom seeks its most stable, restful configuration, the electron drops back down, specifically plunging from the third energy level, known as n equals 3, down to the second energy level, n equals 2, where the exact mathematical difference in energy between those two quantum shelves dictates that a single photon of light is released into the void. This photon always possesses a wavelength of exactly 656.28 nanometers. Because our human eyes interpret this precise wavelength as a deep striking red, we call this phenomenon hydrogen alpha emission. The gorgeous, sweeping crimson ribbons of the Orion, or Rosetta Nebulae, are simply the cumulative glow of countless solitary atoms simultaneously sighing, settling down into their most peaceful, resting energy states. The color isn't painted onto the cosmos. It is a fundamental mathematical rule of quantum physics playing out in absolute isolation, offering a visual blanket of calming red light. Scientists discovered that even the acoustic silence of space conceals a hidden rhythmic texture. While mechanical sound waves cannot propagate through the airless vacuum, the solitary regions surrounding massive planets are humming with invisible electromagnetic vibrations. Take the majestic isolated system of Jupiter. Its spinning core generates an immense magnetic field, creating a protective magnetosphere that extends an astonishing 4.3 million miles outward toward the Sun. Trapped within the magnetic field lines of this solitary giant are highly energetic electrons spiraling at relativistic speeds. As they glide along the invisible magnetic tracks, they generate what plasma physicists call chorus waves. Spacecraft like Voyager and the Juno probe have captured these specific radio frequencies, which naturally occur between hundreds and thousands of hertz. When specialized instruments on Earth convert these electromagnetic vibrations into acoustic audio files, the result is completely unexpected. The silent, irradiated space around Jupiter sounds precisely like a chorus of chirping birds or the whistling of a gentle, melodic wind. It reveals that the silent void is actually humming with comforting electromagnetic energy, a private, hidden symphony playing on frequencies our ears simply cannot organically decode. Invite the sensation of absolute chilling tranquility as we observe the solitary ice giant, Uranus. Drifting far from the warmth of the sun, this world provides a masterclass in extreme solitary planetary mechanics. Uranus is entirely unique within our solar neighborhood because it experiences an extreme axial tilt of 97.77 degrees. Essentially, it rotates perfectly on its side. Because one complete unhurried orbit around the sun takes exactly 84 Earth years, this severe tilt creates a climate of profound, enduring patience. For 21 continuous Earth years, a single pole of the planet is bathed in pale, distant sunlight, while the opposite hemisphere experiences a dark, freezing, unbroken night that lasts for over 2 decades. The aesthetic beauty of Uranus is equally born of its atmospheric chemistry. The planet's upper atmosphere is composed of roughly 2.3% methane gas. As the faint, distant sunlight strikes the planet, this specific concentration of methane acts as an optical filter, absorbing the red wavelengths of light, those around 600 nanometers, and reflecting the remaining light back into space. This chemical filtration is exactly what gives Uranus its smooth, serene, cyan blue appearance. It resembles a flawless, unblemished pearl of pale blue ice hanging suspended in the blackness. Deep beneath those serene cyan clouds, the environment transforms into a landscape of unimaginable texture and pressure. Astrophysicists calculate that approximately 8,000 kilometers below the upper atmosphere, the internal pressure reaches a staggering 1.5 million bars. In this extreme, dark isolation, the immense weight physically crushes the carbon atoms out of the atmospheric methane, pressing them together to form solid crystalline diamonds. These precious stones then slowly sink like heavy hail through the planet's slushy liquid mantle. The solitary depths of these worlds hide physical processes that turn simple, freezing gases into a quiet, perpetual rain of jewels, hidden forever from human eyes, but operating flawlessly in the dark. To truly understand the comforting void, we must examine the very fabric of nothingness itself. For centuries, human logic dictated that if you removed all stars, planets, dust, and light from a region of space, you would be left with a completely empty, dormant box. However, modern quantum field theory proves that true emptiness does not exist. The vacuum of space is fundamentally restless, governed by Werner Heisenberg's uncertainty principle, which allows microscopic amounts of energy to briefly manifest out of nothing. This microscopic phenomenon was mathematically predicted by the Dutch physicist Hendrik Casimir in 1948. In the absolute deepest, quietest vacuum, transient virtual particles are constantly popping into and out of existence in fleeting fractions of a nanosecond. They appear, cancel each other out, and vanish before they can be directly measured. This is known as quantum fluctuation. If you place two microscopically close, uncharged metallic plates in a perfect vacuum, the pressure of these virtual particles appearing on the outside of the plates will actually push them gently together, a verifiable force known as the Casimir effect. Imagine a completely still pond where, if you observe closely enough, an invisible microscopic current creates the faintest continuous dimples on the water's surface, preventing the water from ever truly stagnating. That is the fundamental texture of the cosmic void. The vacuum is not a dead, barren wasteland. It possesses a fundamental simmering energy. It is an unchanging baseline of potential that supports the entire architecture of the physical universe. Allow your awareness to rest on this profound scientific reality. The space between the stars is highly structured, delicately perfumed by ancient elements, painted in specific quantum wavelengths, and gently vibrating with virtual energy. The solitude of the cosmos is never truly lonely. It is an intricately balanced, mathematically perfect environment that asks for no energy, requires no effort, and quietly hums with the foundational rhythms of physics. Acknowledge the deep security in this system, where every wandering atom, every whistling radio wave, and every sinking diamond operates in perfect, undisturbed harmony, keeping time in the exquisite dark. Bringing our observation of the solitary cosmos to a gentle, comforting halt, we begin to trace the elegant mechanics of how this immense universe settles into quietude. The physics of deep space dictate that everything, eventually, reaches a state of profound rest. This step-by-step process is governed by the second law of thermodynamics, which states that all closed systems naturally progress toward thermal equilibrium. Over incomprehensible stretches of time, distinct pockets of intense heat slowly disperse into the surrounding cold, until a uniform, motionless temperature is achieved across the vacuum. It is a fundamental law of physics that chaos always yields to calm. We can observe this soothing process by looking back 13.8 billion years to a critical transition known as the recombination epoch. In its infancy, the universe was a dense, glowing fog of free-roaming electrons and protons, so thick that light could not travel through it. But as the cosmos expanded, it underwent a vital, gradual cooling. Exactly 380,000 years after the initial expansion, the temperature dropped to approximately 3,000 Kelvin. At this precise thermal threshold, a beautiful sequence unfolded. The free electrons gracefully bound themselves to the protons, forging the very first atoms of neutral hydrogen. Step by step, the obscuring fog dissipated, creating the clear, transparent space we see today. The universe organized itself, cleared its own path, and allowed ancient light to travel unimpeded. Our own planet honors this gradual winding down. The Earth's rotation is currently governed by a steady, methodical deceleration. Due to the mechanical process of tidal friction, the gravitational drag created by the oceans bulging toward the moon, our planet's spin is imperceptibly slowing. Astronomers measure this precise braking effect using atomic clocks, confirming that our days are lengthening by exactly 1.8 milliseconds every single century. Furthermore, a true, complete rotation of our planet relative to the distant background stars, a measurement known as a sidereal day, does not take 24 hours. It concludes in exactly 23 hours, 56 minutes, and 4 seconds. The Earth completes its silent spin just slightly ahead of our human clocks, quietly stealing 4 minutes of unseen time every night. As the world turns away from the sun, plunging your immediate environment into the Earth's own shadow, a sophisticated, sequential process begins within your physical form, perfectly mirroring the cosmic cooling. The transition into sleep is not a sudden drop, but an intricate, highly coordinated cascade of chemical events. The sequence begins in your eyes. Specialized photoreceptors known as intrinsically photosensitive retinal ganglion cells constantly monitor ambient radiation. When these cells detect the absence of 480 nanometer blue light, the specific wavelength scattered by a daytime sky, they send a quiet, urgent signal down the optic nerve. This electrical message arrives at the pineal gland, a tiny pine cone-shaped structure nestled deep within the brain's center. Triggered by the dark, the pineal gland systematically begins synthesizing and releasing the hormone melatonin into your bloodstream. As melatonin gently circulates, it initiates a global thermal shift. Your human core temperature systematically drops by approximately 1 to 2 degrees Fahrenheit. This biological cooling process is remarkably similar to the thermal descent of a star entering its resting phase. The blood vessels near the surface of your skin gently dilate, radiating excess daytime heat out into the cool air of your room. You are shedding the thermal energy of your waking hours, physically mimicking the quiet cooling of the surrounding universe. Simultaneously, a molecule called adenosine, which has been steadily accumulating in your brain tissues since the moment you woke up, reaches its peak concentration. Step by step, these adenosine molecules physically bind to specific cellular gateways known as A1 receptors. When this connection occurs, it dampens the electrical activity of your wake-promoting nerve cells. The chemical pressure simply powers down the biological engine. As the nerve signals slow, your brainwaves fundamentally alter their frequency. The rapid, chaotic beta waves of daytime thinking gradually smooth out, eventually yielding to deep rolling delta waves. These slow wave oscillations measure between 0.5 and 4 Hz. Notice how this deeply resting brain frequency perfectly harmonizes with the naturally occurring electromagnetic background of our planet, specifically the foundational Schumann resonance, which rings through the Earth's atmosphere at a steady 7.83 Hz. Your mind is seamlessly syncing its internal rhythm with the slow, resonant pulse of the celestial body you inhabit. The physical descent continues as your autonomic nervous system hands control over to the parasympathetic branch, driven by the wandering path of the vagus nerve. Your resting heart rate smoothly decelerates to a quiet rhythm of roughly 40 to 60 beats per minute. Even at this tranquil pace, the heart efficiently pumps about 1.2 to 1.5 gallons of blood every 60 seconds. Within that flowing blood, billions of hemoglobin molecules rely on a specific ancient element to carry oxygen: iron. We must pause to acknowledge the profound origin of this process. The iron sitting at the center of your red blood cells was forged inside the collapsing core of a supergiant star at temperatures exceeding 5 billion degrees Celsius. When that solitary star could no longer sustain outward fusion, it collapsed and rebounded in a spectacular supernova, casting that iron across the interstellar medium. The quiet beating of your heart tonight is powered by the metallic remnants of a stellar detonation that occurred billions of years before the Earth even formed. By lying horizontally in the dark, you also change how gravity interacts with your skeletal structure. Throughout the day, the continuous vertical pull of Earth's gravity compresses the spine, but right now, resting parallel to the floor, that 1g downward acceleration is neutralized along your vertical axis. Without that compression, the spongy intervertebral discs situated between your spinal bones undergo a process of slow rehydration. Over the course of the night, they absorb surrounding fluids and physically expand, which will actually increase your overall height by 1 to 2 centimeters by morning. You are quietly stretching out, claiming just a little more space in the universe as you rest. Deep within your mind, a vital maintenance cycle initiates. During slow-wave sleep, the brain's glial cells physically shrink by up to 60%. This precise mechanical contraction opens up the interstitial spaces between your brain cells, allowing clear cerebrospinal fluid to surge through the tissue. This fluid system effectively clears metabolic debris, specifically flushing away protein byproducts, like amyloid beta, that accumulate during waking hours. The brain sweeps its own solitary corridors, relying on the quiet architecture of sleep to restore perfect cellular order. As you inhale the cool night air, recognize that every breath is comprised of 78% nitrogen gas. This element did not originate on our world. Nitrogen is primarily synthesized through the CNO cycle, a complex nuclear reaction involving carbon, nitrogen, and oxygen that occurs deep inside solitary stars, possessing at least 1.3 times the mass of our own sun. Every breath you take is a direct inhalation of processed starlight. Furthermore, the solid calcium strengthening your bones right now was fused at 1 billion degrees Kelvin during the silicon burning phase of a massive star's final days. You are entirely constructed from the universe's quietest, most ancient materials. You are not an isolated observer looking up at the sky. You are the cosmos observing itself, finally settling down to rest. Permit the gentle gravity of the earth to hold you perfectly in place. The universe is endlessly patient. It requires nothing from you right now. The stars will continue their slow rotations. The rogue planets will drift silently through the dark. The galaxies will expand outward, creating more room, more peace, and more silence. Embrace these final affirmations of rest. I am made of ancient light and stardust. My body knows exactly how to settle into the dark. The quiet joy of the universe resides within my slowing breath. I am entirely safe in this comforting void. The mechanisms of rest are working flawlessly within me. I am aligned with the slow, patient rotation of the earth. My mind is matching the stillness of the deep vacuum. I surrender my energy to the cooling night. I am anchored by gravity, floating effortlessly through space. There is nothing left to solve, nothing left to carry. I welcome the profound peace of cosmic isolation. My atoms are resting. My thoughts are still. I am entering the quiet dark. Good night.